So since you don't have question regarding the transforms of derivatives, we are going to proceed to the next part, which is the convolution theorem. So when we are using a Laplace transform to solve partial differential equation, the main process is like from partial differential equation, you are going to transform the equation into an algebraic one so that it's easier to solve. Then you are going to transform it back to a differential equation. That's the whole process. So since the transforms of derivative is still the first part because we just find the transforms of our derivatives. So the next part to that is to get the inverse of our transform of derivatives. Okay, so the convolution theorem is mainly helpful in getting the inverse of our transform of derivatives, which is transform of derivatives where the two function where you multiply the two transforms. So here the convolution theorem states that the inverse of two Laplace transforms is equal to the g convolution of f is equal to the integral of g t bar times f of t minus t bar dt bar from 0 to t. Okay, so here we have f of t is the Laplace transform, the inverse Laplace transform of f of s, and g of t is equal to the inverse Laplace transform of g of f. So equivalently, the convolution theorem states that the Laplace transform of this, which is the convolution of g and f, is equal to the product of the two Laplace transforms. Okay, so in dealing with two Laplace transform, we have our addition. When we add the two Laplace transform, we are just going to distribute the Laplace transform. In multiplication, it's not possible that you distribute. For example, if the Laplace transform of, let's say, f prime of t plus 3y is, let's say, 4y is equal to 3. Here you can distribute this. You can say Laplace transform of f prime of t plus the Laplace transform of 4y is equal to the Laplace transform of 3. Okay? But in multiplication, you can't do that. Okay? It's not possible. So here, if you're going to, it's not possible. So here, if you are going to have convolution, the Laplace transform of a convolution g and p, is equal to the product of two transforms, which is f of s and g of s. So here we have our equation that we have to remember in order to use the convolution theorem. Okay, so I will show you an example. Here, this will just be your assignment. Okay, so please take a picture of it. So let's proceed to the inverse. Since it's very important to find But if you are going to find the inverse of something like this, like this one, this Laplace transform is not found in the table. So we are going to use the convolution theorem. Okay, so let's proceed to the example. So we have the inverse Laplace transform of 1 over s times s squared plus 1. So since it is defined that the Laplace transform of a convolution is equal to the convolution, the product of the two Laplace transforms. So here we have the inverse Laplace transform of, wala ko na natin silang buka. So 1 over s times 1 over s squared plus 1. Okay. So this is our f of s, which is, this is the Laplace transform, okay? And the second Laplace transform is g of s. Okay. So since here it is equal to the convolution of f of t and the convolution of f of t and g of t. Okay, so the f of t is the inverse of the Laplace transform. So what the inverse Laplace transform of 1 over s is equal to, yes, very good, 1. So 1. The convolution of g is equal to the convolution of the g of t is the inverse Laplace transform of this. So what is the inverse Laplace transform of 1 over s squared plus 1? Is sine t. Very good. So since the convolution is commutative, so pwede natin yung mabalik-balik na sa matter. Pwede hindi mo rin mabalik. Wala yung mausok. So we're going to write this as sine t convolution 1. So mabalik na ang ilang mabalik na sila. So this will become f of t convolution of g of t. Okay? Next step, Anna, is we are going to perform the convolution of this. Okay, so f of t convolution of g of t is equal to the integral of f of x times d of t minus x dx. Okay, so here, let us substitute the value of the f of x and the g of x and g of t minus x. So our f of t will be, this is our f of t and this is our g of t. Okay, so the value of f of t is sine t. Pag imo na siyang i-substitute dire, mahimo ang t mahimo x. Okay, so this will be sine base na siya of t minus x. So since 1 naman, there's no changes lang. Then dx. Okay. So since 1 na, pwede na natin wala on 1. Okay, it's the same thing. Okay, so what is the integral of sin x? Of course, negative cos x runs from 0 to t. Okay. So, if you take continuation with this, so there is one. This will be equal to negative cos t minus negative cos 0. So, negative cos t, negative times negative, positive cos 0. Okay? So we have negative cos t plus cos 0 is equal to 1. Okay. So this will be equal to 1 minus cos t. And that is our final answer.